Hi, this video will be about the third chapter in the book, The Compass of Pleasure by David Linton. I hope you're not hungry right now, as it's going to be all about food. We will start with biological food regulation, both long-term and short-term. Then, how food is connected with pleasure and stress, and all about obesity. So let's start with long-term food regulation. Our body is made to maintain a relatively constant balance between the calories you consume and the calories you burn. This is how you naturally keep your weight constant. But how does this work? Here's where the hypothalamus comes into play. It receives signals to modulate appetite and energy expenditure in order to maintain weight in a narrow range. More specifically, there are two areas that are responsible for these functions. The lateral area, which is known as the hunger center. Damage to this area leads to leanness. And the ventromedial area, also known as the satiety center. Damage here leads to obesity. But how does the hypothalamus know about your weight? This is leptin's job. Leptin is a hormone that reduces appetite and increases energy expenditure. Its receptors are found in the hypothalamus, and it is produced by fat cells. So if weight is lost, fat cells are also lost, and so is leptin. The hypothalamus notices this decrease as less receptors are activated. This triggers more food intake and reduced energy use, eventually leading to weight gain. In contrast, if weight is gained, increased fat mass causes leptin to rise, suppressing feeding, thereby increasing metabolism and activity to burn more energy. It results in weight loss. But in the moment of eating or feeling hungry, how does the hypothalamus know about your level of hunger and satiety? In other words, how does the short-term food regulation work? Your stomach and intestine contain sensors in their cells that provide the necessary information about the ingested food. There's chemical information such as how much sugar I ate, or what are my concentrations of gut hormones, and mechanical information like how much is my gut actually stretched. Next, gut hormones are activated and send signals to the hypothalamus. This information is being sent to the brain via a fast and a slow pathway. Within the fast pathway, mechanical and chemical information is sent with neural signals via the nucleus tractus solitarius pathway. As a result, the neuron subset in the arcuate nucleus is activated. This in turn sends signals to two other nuclei in the hypothalamus that are responsible for either satiety or hunger feelings. In the paraventricular nucleus, CRH is secreted, which stimulates the feelings of hunger, while in the lateral hypothalamus, orexin is secreted, which stimulates the feelings of satiety. Within the slow pathway, circulating leptin levels from fat cells signal the nuclei in the hypothalamus if you have eaten or you need food. Therefore, leptin plays a role in the long and short-term regulation of food. So this is how food regulation ideally works, but always keep in mind that there are many other factors that can influence your feelings of hunger or satiety. For example, the time of the day, people around you, and your mood. Until now, we have seen that our brain has developed the mechanisms to maintain a steady weight. But then why do so many people have problems with being overweight? One reason is that food activates our pleasure system. You probably know how rewarding it can be to come home after a long day of university and eat a piece of chocolate. Well, this has to do with the fact that food activates our pleasure circuits, just like drugs can do. This was shown with experiments where drugs that activate dopamine, like cocaine, led to a reduction in hunger. Since dopamine receptors are already activated by cocaine, food does not have a strong impact anymore in that moment on dopamine receptors. Therefore, it has been concluded that food activates dopamine pathways that are responsible for experiencing pleasure. However, for some people, like when dieting, this piece of chocolate is more rewarding as for others. So why is this? It again has to do with leptin. Leptin can bind to the receptors in the ventral tegmental area, which contains dopamine neurons and is part of the pleasure circuit. As soon as they bind, firing is inhibited, and so less leptin is released, making eating less rewarding and frequent. On the other hand, people who diet have lower levels of leptin, since they lose fat cells. Consequently, less leptin binds to the VTA, so less inhibition and more dopamine. Since the increased dopamine makes food more rewarding, it thereby makes dieting harder, and you crave that piece of chocolate so badly. There was an interesting experiment by Eric Stice, where women were put into a brain scanner while drinking sips of chocolate milkshake. Results have shown that obese participants showed less activation of the reward circuitry than lean participants. However, they showed greater activation when about to get a milkshake. This shows us that obese people expect more reward, so crave more for the chocolate, but actually experience less. So chocolate is less rewarding than expected. An additional factor that plays a role in eating behavior is the experience of stress. Think back to a past exam period when you came home after a long day in the library and felt super stressed. Some of you may remember that you were eating more, especially high-calorie comfort food, while others may have not felt any hunger. This has to do with the activation of the HPA axis, which is our slower response to stress. It starts with the release of stress hormones in the hypothalamus. What happens is that CRH, which is corticotropin releasing hormone, is secreted by the hypothalamus during stress situations. Through the bloodstream, it reaches the anterior pituitary gland, which secretes ACTH, which in turn stimulates the adrenal cortex. Here the stress hormone cortisol is released. And since we know that cortisol helps us mobilizing energy to fight a difficult situation, like upcoming exams, we eventually eat more to gain more energy. Therefore, such long-term stressors can lead to overeating. Since all the biological systems that we have explained so far have developed at the time of our ancestors, our system is not accustomed to the unlimited availability of food. Not only is it unlimited, it is also easily accessible. Think of how many restaurants and supermarkets are around us now. And our diet today is also high in sugar, fats, and salt, which were not part of our ancestor regular diet. Our brain is hardwired to crave for these high energy dense foods, which used to serve as reserves. Due to this mismatch between our diet and environment nowadays and the ancestral one, as well as the increased presence of long-term stress we have to deal with, obesity. It involves an excessive amount of body fat, and worldwide it has dramatically increased in the last decades. Moreover, obesity increases the probability of developing cancer, heart disease, diabetes, and many other health problems, and is linked to the leading causes of preventable death. So what can be done about it? The first thing that comes into mind is a natural weight loss such as a diet. However, homeostatic systems work against such efforts as they increase appetite and slow down our metabolism. And our food regulation happens less conscious as we always tend to think. Actually, 80% of our BMI is determined by genes. Therefore, scientists have come up with other interventions. For example, bariatric surgery, which is however very risky and expensive. Another method are anti-obesity drugs. It has been tried out to give obese people leptin. But does giving leptin help? No, as obese people already have high leptin levels, so it does not really have an effect as they are leptin resistant and not deficient. Other drugs have been developed and showed promising results but had severe side effects. Due to the rising number of obesity, the potential market of anti-obesity drugs is huge, and so is the effort put into developing other effective drugs. So far, we have heard a lot of information, but here are the main points that you should remember. Over the long term, our hypothalamus keeps weight balanced by sensing hormones levels like leptin. Over the short term, appetite is regulated by two pathways, neural and hormonal, which also activate nuclei in the hypothalamus. Food activates the pleasure circuit, or the dopamine system, and is therefore highly rewarding, just like drugs. Stress can influence our food regulation through the activation of the HPA axis. Our biological system does not match the environment nowadays. Obesity is a major health problem, and further research has to be done. And last but not least, our question to Professor Linden. Given that natural weight loss is difficult due to the previously mentioned reasons, and no effective nor safe drugs have been developed, what would you advise to tackle the problem of obesity in our society?